Well, a warm welcome also from my side. I'm going to introduce the concept of passive house to you during this very short presentation. Um, yeah, so what is it, a passive house? Well, first of all, it's real building. It has been built for several decades right now. Uh, it doesn't look very different from what you normally accept to be a building. So to understand how it works and what it is, we have to look a little bit closer. So let's look at the cross section of that building that was actually built as a university building. In the cross section, we see that we have a quite good insulation. That this insulation is made in a way that we are avoiding additional losses by thermal bridging, and that we use good windows which are available nowadays everywhere on the market. We make it airtight, and we have exceptional good indoor air quality by using a heat recovery ventilation system. And that's it. It's just 5 principles. But these principles, they have consequences for that building, because the overall consumption for heating of such a building will be reduced by 90%. And this is performance-based. So these are real measurements of really existing buildings. So the average consumption of buildings in Europe in this respect for heating is around 130 kilowatt hours per square meter a year. These passive houses, it's only 1/10 of it. So are these savings reliable? So there is a presentation and a publication just about this, which you can read by following the link given here. And I just cite one of the figures in that publication showing the average consumption of average new construction in Europe compared to the average consumption of passive house settlements, which have already been built, measured consumption. So what we see here, we really get these around 14 kilowatt hours per square meter a year on measured consumption in these buildings. So we are really down to this very, very low amount. That's, of course, then a very high contribution to our change of the climate impacts and of the energy we use in the buildings. Can we do this also in existing buildings? And the answer here is yes, and it's also already been done. The average consumption of typical existing buildings in Germany, it's around 200 kilowatt hours per square meter a year. And the refurbished buildings, which have been demonstrated what we can do with the same kind of technology which is used for the passive houses, new ones, is around 85% in this respect. We can also have a look with a thermographic camera. This is, of course, very interesting to see also from a technological point of view. It's a different kind of electromagnetic wavelengths we are looking at these buildings. And what you see here is that these warm colors you see here, these are the surfaces of the old building, which isn't insulated very well. And here in front, you see this refurbished building, which almost loses no energy anymore. So this is working. How much can we save? Well, it's a little bit depending on the kind of building we are dealing with. So if we just do what is normally done, the savings are within a range of 25 to 30% in the conventional manner. But if we can do all the passive house measures in an existing building, we will reduce by about 80 to 90% and come down to 25 kilowatt hours per square meter a year. There are some buildings where you can't do it because we are protected. You cannot change the facade, and then we will only be able to use internal insulation. But there we still can save about 75%. The key for all of that is the improvement of the components used in the buildings. And let me just show that with an example. This is a typical window, and a manufacturer of a window, he comes to the experts, and when we are looking at these developed new component, we can calculate what the energy losses of that component will be. It might already meet the criteria for a passive house component, and if not, we help the manufacturer to improve his component, and that might take 1, 2, 3, whatever loops. But at the end, the product will be improved by at least a factor 2. It can be up to a factor 8. So these improved components will be available on the market, and this is the way that the losses in the existing building stock will be reduced step by step. Where can you get further information? Well, there are some of the latest publications. We have, for example, seen that these kind of buildings at the end can be heated by just one single air conditioning system, split unit system, that's published in the latest publication of the University of Innsbruck. We have just started a campaign called Efficiency Now, where we tell people what they can do right now in face of the existing crisis with low gas delivery from Russia. So what can we do right now? And it's a lot of things we can do, and you can find this following the link given here. You find a lot of these informations on Passipedia. Again, passive houses are not just an idea. It's not just a topic of research. Well, there's still a lot of research going on, but it's now a widespread international successful solution. And all these buildings you see here, they are all passive houses or retrofitted existing buildings. What is the impact of this on the real world? Well, it's quite interesting to see, because if we really engage in improving the existing buildings, what in Germany has been done in the time between the year 2000 and 2010, you can reduce the heating demand by about 30% in 10 years. And it just stopped in 2010 because everybody believed that now we have much cheaper natural gas, and so it's not important to do that any longer. And so this is what the result would be if we do nothing, and this is the result if we improve our buildings. So this can, of course, be done again, and this way we can deliver what we need to make the energy transformation successful. I thank you for your attention.